Aloha. This is Matthew with Aloha Autonomy, and we're going to be doing a demo of some of the products we've been developing for the SDA TAP lab. And so the first product we have here is an ascent trajectory calculator. Now this tool works in both left of launch and right of launch instances. The tool which you're seeing here is for the left of launch instance. And so what it does is it predicts the ascent trajectory of a launch vehicle based on certain parameters. Those parameters include the thrust and the mass of the rocket. So this is dependent on each vehicle. And so for here, we have the thrust and the mass for a Falcon 9. You want to get your initial and your terminal steering angles. So these are the constraints on the 2-point boundary value problem that you're going to be solving. And so for the right of launch instance, what we're able to do is reconstruct what the terminal steering angle is based off of some intermediate measurement of the vehicle downrange, some time delta after the launch. And so that's going to inform the equations of motion. And then you're going to have the bearing, the latitude, the longitude of the launch site. So it's which spaceport that the vehicle is launching from. And then you're going to have the start time and the end time of the launch window. And so what this does is it'll generate ascent trajectories in ECI coordinates. And so it rotates with the Earth. So if it's an hour later, it'll have rotated about 15 degrees further on the right ascension for the launch nominal you're generating. And then you can partition that time window into different things. So if you have a 24-hour interval, you could do a partition interval of 24 and you get 24 1-hour intervals, which you're generating ascent trajectories for from this given location. And then finally, you have the latitude and longitude of the bounding box. So this is pulled from an exclusion zone, whether that be a notice to airman, a notice to mariner, or just an arbitrary box you want to see if the launch vehicle is going to be heading in. And so what happens when this executes is it'll generate a JSON where it has the ascent trajectory and ECI coordinates. And so if you have the partition interval to have multiple trajectories within the partition, it will then generate multiple trajectories, hence designated by the trajectory ID. And then it'll tell you the epoch that it's launching at. And so what you can see here is the trajectory. So the timestamp, X, Y, Z, and ECI, and it does that for each timestamp in the interval. And so this is starting from the epoch and goes all the way until about 600 seconds, which is what we defined as the cutoff time. Now, for our second tool, we have a NOTAM to TLE correlator. And so what this tool does is it correlates exclusion zones found from open source intelligence and correlates them with the TLE. So the use case of this is for UCT processing or for associating launch nominals with actual open source intelligence. So what the tool does is it takes in a window start and a window end. So this is to see if during that window there could have been a launch which physically could have generated that TLE. And then again, you have a time partition here. And so right now the tool only takes in a nominal inclination and nominal right ascension. So those are the two terms we're matching up to see if the plane lines up to the exclusion zone. And then you're going to have the bounds on your exclusion zone. You're going to have the launch site where you believe that the vehicle has launched from. You're also going to have vehicle parameters such as thrust or mass. So these are included here because if the thrust is higher, it'll go further down range, hence having a slightly different orbit. And so this is to account for that. And then you have the tolerances on the inclination and the right ascension. So this is if you want to have plus or minus 1 degree and many degrees, and you can have an upper tolerance lower than a different tolerance if you have a hard cutoff. And so what will happen when you run this tool is it'll return Booleans. So true, the inclination matches, but false, the right ascension doesn't match. And so if both of them match, it'll then return the epoch that it would have had to launch in order to match that right ascension. So you can help to screen when a potential launch could have occurred. After this, we have another tool, which is our polygon scraper. So if you want to get exclusion zones from the web based off of the launch site, you can actually scrape for them. And so this way you don't have to do it manually. And so the only thing that it takes as an input is an ICAL code. So this is associated with the airspace that launch vehicle could be traveling at. And so what happens when you run it is it'll scrape the web and it'll pull results for both C lane closures and airspace closures. So here you can see the C lane polygons and it gives you the bounds. And you can use these bounds to go directly into our ascent trajectory calculator or our NOTAM to TLE correlator. And so you can just see it generates a bunch of them. So it's all available open airspace or C lane closures, and it doesn't look like there's any airspace closures captured in this one. Then finally, we have one more tool, which is going to be our launch vehicle pattern of life characterization. And so what this tool does is it takes in a site code of where you want to launch from. and it takes in a start date and end date of when you want to screen, and it takes in the latitude and the longitude of the launch site. And what it'll do is it'll tell you the historical launches that have occurred. And so what happens when we run this is it will fetch the NORAD IDs associated within the spaceport for that given launch window, and it'll return the NORAD IDs of the satellites, and then it'll group them by bearing. So the two satellites that launched from Juchuan within this time interval, they both flew at a bearing of 86 degrees relative to the launch site. And what it'll do is it'll sample a series of bearings of coordinates that would have been along that bearing. And you can use these to then search for iCal codes, which then can be used to scrape for NOTAM. And so you can find historical NOTAMs based off of this. And that is a demo of some of the products we've been working on. A hui ho and aloha.